Welcome back. In this lesson, we're going to look at the three basic ways that atoms will combine to make bonds. We're going to see ionic bonds, which are stealing or getting stolen from the valence electrons. We're going to see covalent bonds, in which the valence electrons are shared. And then metallic bonds, which is a unique property of metals where the valence electrons from every atom in that metal is actually not around its nucleus, but around the entire surface of the metal. That allows the metals to be conductors of electricity. The first bond we're going to look at is ionic bonds. And ionic bonds come from the word ion. And an ion is a charged particle. Okay, so for instance, if you were to have an atom, okay, let's say the atom has 10 protons and 10 electrons, and the electrons are all in orbit around the nucleus. Well, that is not an ion because these charges are neutral. If you were to have one extra proton, so for instance, I have 10 protons but only 9 electrons, so somehow I've lost an electron. Well, you're going to have a charged particle there, and it's not going to be neutral, it's going to be a positive, and this is called a cation. Okay, a positive particle, positive charged atom, if you want to think of it as an ion. If you were to have a bigger number of electrons, such as 11 electrons, but only 10 protons, okay, so this is 10 negatives, 9 negatives, 11 negatives, you're going to have one extra negative, which means that the whole ion is now, it is an ion now, it's a negative ion, and a negative ion is called an anion. So when a cation and an anion attract, they're attracting not really by chemical forces at all, but by electric forces. You have an electric force which takes two oppositely charged particles and attracts them together. Two positive particles would repel each other, two negatives would repel, but a positive and a negative attract, so opposites attract, and this would be a bond formed by ions, and so therefore it's called an ionic bond. Not necessarily sharing anything, not sharing a bond of electrons, but instead a positive and a negative cation, anion combination coming together and statically or electrically combining. To review then, if you lose electrons, then you're more positive. If you gain electrons, you're more negative. I think of ionic bonding as stealing electrons and becoming more negative yourself, or getting stolen from, getting one of your electrons stolen, and then you becoming more positive. Here's an example, sodium chloride. Sodium chloride is made up of a sodium atom which becomes a positive ion by giving away an electron, and a chlorine atom that becomes a chlorine ion by stealing an electron. So if one of the electrons is stolen and brought into the chlorine cloud, then you're going to have more electrons. You're going to have 18 electrons, but only 17 protons. That means the entire ion will be negative. You're going to have a negative ion. Once I've stolen one of the electrons from this cloud, I only have 10 electrons left, but I have 11 protons, and so that means I've got one extra proton. This will be a cation, which is positive. The chlorine will be an anion, which is negative, and now those two charges will attract each other by electrical charge. It's important to note that when you have sodium ion, the properties of sodium ion are different from the properties of sodium metal. By taking on that extra electron, all the properties or the things that are true that you can observe about that sodium is no longer the case. So sodium is soft, it's squishy, like really hard peanut butter or cream cheese. It's silver colored. It can really, really quickly turn black in the air because it reacts with the oxygen in the air. It's toxic. It would be poisonous, so you wouldn't want to eat it. It blows up when you put it in water. All those are the properties of sodium. The properties of chlorine is a gas. It's green. It's was used in mustard bombing of the trenches during World War I. It was used in gas chambers. It is a chemical weapon banned by every country in the world. It's used. It was used in Syria. But in any case, a green poisonous gas. When it becomes a chlorine anion, it's no longer green or gas or poisonous. And the sodium and chloride ions coming together to form sodium chloride makes table salt. And you know what table salt looks like. It has completely different properties, and it's not dangerous at all. It's necessary. The second type of bond is called a covalent bond. Valent comes from the valence electrons, which is the outer shell of electrons. And these outer shell electrons are being shared, not stolen this time, but shared, and the number of valence electrons will count for both of the atoms involved in the bond. So co meaning together, so like a company or to collaborate, something together with. So those two valence electrons are being shared by both of the atoms in the bond. So in the case of, say, a hydrogen gas, hydrogen has one proton in its inside, and so it has one electron outside. It's not stable with one. The first shell is stable with two electrons. So it needs to share another one. Well, it can share with itself. Each of the hydrogens would bring one electron, and then they would both share both of those electrons. By those electrons being very, very close to the nucleus of both atoms, the electricity is stable. It's a lower energy as a bond than it would be as an individual atom because it's not stable as such. So putting them together, they would have one cloud that's surrounding both nuclei. The nuclei are not very, very close because they are both positively charged and they repel each other because like charges repel. But the clouds would go around both, and they would pull equally to those electrons because they have the same amount of pull. Each nucleus has one proton in it, and so they're going to pull equally, and so there's going to be a equal sharing of those electrons. Here's an example. Oxygen has 8 electrons. 2 are in the inside shell. 6 are in the valence shell or the outside shell. So in order to meet the octet rule, oxygen needs to share 2 electrons, and those 2 shared electrons will count towards the oxygen's octet of 8. Hydrogen, remember, is in the first row, and so it doesn't need 8 to meet its octet. It really only needs 2. So it needs to share its electron that it has with one other electron so that it will count towards its total valence, full valence shell. So since oxygen has 6 and needs to share 2, it's going to share 2 by sharing 1 each with 2 hydrogen atoms. So this is the molecule of water. Water is hydrogen, it's H2O, and water is a covalent bond, and as such, this whole thing, all of it together, is called a molecule. A molecule is the smallest unit of a compound that's covalently bonded. The last of the bonds is the metallic bond. In a metallic bond, the valence electrons are not around each nucleus. All the nuclei and their inside electrons are beside each other in a matrix. So imagine a wire of copper or a wire of silver, all of them next to each other, one after the other. And the outside electrons that normally would surround individual atoms, all those electrons are free to go anywhere in the entire metal. So they are delocalized. And as delocalized, they can travel, and that is what you want it to do if you want electricity. Electricity is the piling up or the transfer of electrons through some kind of a conductor. And a metal is a perfect conductor of electricity because of all of these delocalized electrons in a metallic bond. The other thing that's true of metals for this reason is that you can stretch them, okay? Because these delocalized electrons allow them to be pulled and readjusted. You can hammer them into sheets. They're malleable. They usually have rather low boiling points or melting points, so you can iron takes a lot of heat to melt iron, but it's not impossible to melt iron. You can get a furnace to melt it. So yeah, there's a lot of advantages because of this special kind of bonding. It really doesn't do a lot in beginning chemistry. Mostly you're dealing with covalent and ionic bonding.